One of the critical things is, who is the Grandmaster? The ultimate source of time on your network. And this is calculated using an algorithm called the best Master Clock Algorithm, or, if you've been following SMPTE, the best Transmitter Time Clock Algorithm. And there are a couple of parameters you need to be aware of here that run within this. And the first one of those that you can adjust is known as priority 1. Now, the default 127 value should be changed to a lower value, but above 0, and all PTP sources should be the same. But we'll go into the architecture of how you scale and number priority 1. Clock class, this is the clock accuracy. And you have a level of control over this, because if you have a GPS antenna, obviously you really want to connect it to that. But if you can't connect it to that, maybe you're going to use house black, or maybe you're going to lock it to PTP from another source. And the final piece that you can control is priority 2. And again, we're going to show you how you would set this up in a few minutes. In the unlikely event that your clock class priority 1 and priority 2 are identical, we have a final tiebreaker, and that's the clock ID, the MAC address. And as MAC addresses are unique, no two devices can have the same MAC address. Therefore, you can never have two Grandmasters competing with each other. So let's take a look at the network. And this is a very traditional leaf and spine architecture. And really, you want the PTP and the best Master Clock algorithm to be running at what we call the PTP distribution layer. You will have ports configured as PTP masters and ports configured as PTP slaves on your network. And what we also recommend is that between the PTP distribution switches, you create a VLAN. And this VLAN is used to carry PTP. So this is the only connection between the red and blue networks. Everything else is completely isolated. And if you need to add black and burst, tri-level sync, word clock to a studio facility that's part of your IP infrastructure, that can simply and easily be added and then locked to PTP and connected to an emergency changeover, as you would do with a traditional black and burst and tri-level sync reference system. So what actually happens with this whole process? So let's take a look. We're going to select the Grandmaster on this very simple system, and we're going to switch the devices on, and they start listening to each other, and announce messages start traveling through the 2110 network. And once all the devices have had their say and announced their condition and status, the best Master Clock algorithm will select one of the devices to be the Grandmaster. And in this particular case, it's selected GMA, because priority 2 is 1, whereas on GMB, priority 2 is 2. And as I said, you need to design this such that should a failure occur, and here we see we've lost the GPS reference, we've changed from clock class 6 to clock class 7, and the announced messages are continuing to flow through the 2110 network, and a more suitable Grandmaster, namely GMB, will take over because it's clock class 6.